Hi there. In this video, we're going to dive into the exciting world of Kubernetes and explore how to create a Kubernetes K3S cluster using two unique approaches. We'll be focusing specifically on Alpine Linux servers. This is something you won't find anywhere else. If you are using Raspberry Pi for your Kubernetes cluster, this is for you. We're going to kick things off by showcasing the creation of an Alpine Linux Virtual Machine. It's the first step towards unlocking the power of Kubernetes. We'll take it a step further and demonstrate how to set up K3S Cluster with master and worker nodes. These innovative techniques are made possible thanks to our very own creation, the K3S_auto_cluster_generator tool. We recently developed and published it on GitHub, and it's a game changer when it comes to scripted deployments of Kubernetes K3S clusters on Linux servers. Now let me introduce you to our Kubernetes expert, Nico, and his captivating Dodecanese Italian accent. Don't worry though. Nico speaks fluent Queen's English. And without any further ado, over to you, Nico.
We are now going to create an Alpine VM in our Proxmox server. If you look down below, you'll find a link to our blog and get the information you need. We need to open a primary node in our Proxmox server, click on it, and then click Create a VM. I'm going to use the 500 range, 502. I'm going to give my server the name Alpine 97, where 97 is the last digits of my IP address. So that way I can know which IP address I'm using. Click Next. I've already downloaded the Alpine standard image. This image is 198 megabytes, so it's a very small image. After selecting the ISO image, we press the Next button. There's nothing to change here. Next. I'm going to allocate 100 megabytes to this as it's a Kubernetes cluster, and I'm running this on my Proxmox server where I've got a terabyte of data available. However, if you're running this on a Raspberry Pi, you will definitely want to consider a different size. I have one socket, but I'm going to have two cores. This will be fine if you were running on a Raspberry Pi, but I'm running on a bigger server. I'm going to allocate 4 gigabytes of RAM. And we've now created the VM. Next we need to start it. So let's click on the VM and open the console and start it. Login as root without a password. Now there are certain things I need to do. I need to run setup-alpine. I need to choose a keyboard. I'm going to use US and again US. Now for the host name, I want to use this host name as I already have a DNS record for it. So it's lion.loseyourip.com. This runs on a local network, so don't bother to try and see if you can ping it or connect to it. You won't. Now we want to select the Ethernet, which is ETH0. And the IP address I have over here unfortunately, you can't copy and paste into this terminal, so you have to type 10.154.2.97. Netmask I will accept, press enter. Gateway, my gateway is 10.154.2.3. Now it asks you if you want to do a manual network configuration. Just press enter. The answer is no. Domain name we are going to type again lion.loseyourip.com. The DNS server, I'm going to use Google 8.8.8.8. Now we need to give a root password. And retype it. Time zone, I'm going to keep it as UTC, so press enter. I'm not setting up proxy, so press enter. For a mirror, I'm going to use 1. Q and press enter for the default. Set up a user. I don't want to set up a user, so I'm going to say no. I want to use OpenSSH, so press enter. Allow, I want to say yes to allow root to log in. I don't have a SSH key, so I press enter. It asks me which disk, but it's displaying that SDA has a 107 gigabyte space. So I'm going to say SDA, enter. And here I type sys, SYS. And erase, yes, I want to erase the disk. It will erase it, format it, and continue with the installation of Alpine Linux. This takes a few seconds. And now we are ready. So after having done all of these things here, I've got some additional things I need to do. The first thing I need to do is enable the repositories. If you type ls-la/etc/. APK. Enter. And there you will find the repositories file. So I need to edit that with VI. And it's brought up repositories. Now you need to hit the I button on the keyboard, move the cursor down, and delete the hash. And to save, it's escape:WQ. And now that I've done that, I need to add nano and curl and tree. So the command is apk add nano. After installing nano, I need curl. And then I need tree. Tree will be useful when I'm working with Kubernetes. An additional item to install is htop. apk add htop. Let's test it. htop. You can see this thing is using very little resources. This is quite a light machine. Our server is now ready to install Kubernetes on it. You need to go to our cluster generator. We will provide a link below. And if you go here to the code and you select this, you can then git clone the project. I'm not going to run it because I already have this in this particular folder. I've already cloned this project. And this is what you will get. Now, if you go to the examples folder, you will see that we have a folder called K3S Alpine Cluster. So we open that folder, cd K3SA tab. And here we will find a YAML file, config.yaml. You need to edit this file. When you open this file, you'll find it consists of three parts. The first part is where we define the primary Kubernetes cluster node. The second part is where we define additional master nodes. In this case, I haven't defined one, and I've made the name of the script deletemE.txt, so it's not a shell script. If you want to, you can add as many of these as you need. If you want to make a high availability cluster, then you would have 3 master nodes, so 1 primary and a minimum of 2 secondary master nodes. Okay, now that we've done that, this part here is where we define our worker nodes. Currently there is 2 worker nodes. This is already running in my Proxmox machine, and it's also deployed to the Kubernetes cluster. But here is the new one. So this is the details: the IP address, the fully qualified domain name, the user ID, and the description for this. And this is the name of the shell script that we are going to generate to create this server as a Kubernetes cluster node. And then this part here is for the schedule. Leave this, don't change this. After we've made our changes to this file, then we save it, Control S, X. Before we can run this Python script, we need to make it executable. So it's chmod 775 and then the name of the script. So it's copy, paste. And this now makes our script executable. Now we can run the script ./a. And when I run this, it'll tell me that it's generated these, the master and 2 worker nodes. And it's told me also what the shell scripts are for those. And here was the second master node. I called it delete me. So here's all the files I need. In addition to that, there is a shell script that gets created. When you have a Kubernetes master node and you want to destroy it, you run this on the master node and it'll destroy it so that you can reinstall. And the same with the worker nodes. So if I create a server and I make it a master node, I would run this when I'm finished so that I can make it a worker node. If I want to downgrade it to a worker node, I first delete the master node and then I do the reinstall. I run the appropriate shell script. Obviously, I would need to edit the config file. And that's it for this. I am now going to create the Kubernetes clusters using the new virtual machine that I created. First, I'm going to demonstrate how to create a primary master node, and then I'm going to destroy it, and then I'm going to demonstrate how to create a second worker node. So the shell scripts that I created with the tool I'm now going to use. To save me time, I've copied the shell script into a text file so I can copy and paste it into the terminal. I'm also going to connect to my VM with a terminal from my Linux machine using the SSH command. I now need to use APK to add nano. And also curl. On this server, I'm just going to take the commands and paste them in. And the next command is curl. This is downloading from GitHub, the latest, and it's installed it. I should be able to run a kube control command. And you can see I've now created a Kubernetes master node. I need to destroy this so that I can create the worker node as a member of my existing cluster. Before I do that, there's one command we need to type. This command here is important. What this does is it gives us the token. So if you want to get other machines to connect to this Kubernetes master node, then you need to use this. So in our case, we need to go back and edit that config YAML file and update the master node's token in there. However, I've already done that for my existing server. Now, if you look at the bottom here, I've got the commands to delete a master node. This is it. First, I have to kill all apps. And then I do an uninstall. Now we do an uninstall. Now we can clear the screen. And now we can continue with our shell script that we created to create a worker node. In a Ubuntu and in a CentOS machine, I could run the shell script as is. However, in this, I'm having a problem running the shell script. You can maybe give me a comment below what I'm doing wrong. So I'm just going to copy and paste this in manually. I've now specified the token to authenticate. I'm going to open up my Proxmox server to show you what I'm about to do. Previously, I had created this VM. However, this is the master node, 93, and this is one of my worker nodes, my first worker node. So I'm now creating a second worker node. And that's what I have here. The next line I need to run is this. I'm specifying the URL of the primary node. It's 93. That's the IP address. And the port is the Kubernetes port to communicate and create my cluster. So let's enter that. I also now enter the name of my worker node. It's Lion, lose your IP. And finally, I run the curl command. I'm going to open up another tab. At this point in time, I would like to SSH to the master node. I should now be able to run a kube control command to get all the nodes. The command to get the nodes is kube control get nodes. And here we can see that Lion, we've just created Lion a few seconds ago. And with that, I hand you back to Josh.
In conclusion, we have learned about the exciting world of Kubernetes and explored two unique approaches to create a Kubernetes K3S cluster using Alpine Linux servers. We started by showcasing the creation of an Alpine Linux Virtual Machine, which is the first step towards unlocking the power of Kubernetes. Then, we went a step further and demonstrated how to set up a K3S cluster with master and worker nodes. The key to these innovative techniques lies in the K3S_auto_cluster_generator tool, which we developed and published on GitHub. This tool is a game changer when it comes to scripted deployments of Kubernetes K3S clusters on Linux servers. We hope this video has provided you with valuable insights into Kubernetes and the creation of K3S clusters using Alpine Linux servers. Remember to explore the possibilities and continue learning to harness the full potential of Kubernetes in your projects. Thank you for joining us, and until next time. We hope you found this lesson insightful and engaging. If you enjoyed it, don't forget to show your support by subscribing to our YouTube channel and clicking the like button below. By becoming a patron of this channel, you can further contribute to the creation of more valuable content like this. Stay tuned for future lessons and exciting adventures in the world of Kubernetes. Thank you once again, and happy exploring Kubernetes.